Hey guys, I'm back. Gonna be talking about solving differential equations today. This is a pretty big topic when it always comes to the AP, the actual test. Every single year, we always get the free response questions back. They get released, and there's always a question about solving differential equations that shows up on the AP test from year to year. Now, granted, this year you guys only have to do 2 free response questions. I would bet some money that solving differential equations would probably show up somewhere within that free response questions. We're going to start reviewing here next week. The AP Central has started putting out some basically review videos of topics, and then I've also been putting out some videos where teachers are teaching lessons, just in case teachers can't post lessons, so they can use that for their classroom. But a couple of the very first things that they were putting out were involved with solving differential equations. So I'm going to guess that this is going to show up on your test here in May. So let's just talk about this real quick. So the idea is that you have an implicit derivative, meaning that you have y and x's kind of showing up. And we are trying to take the antiderivative to find out what the original equation would be implicitly. So there's a couple of main ideas that you really want to do with these. You always start off with some type of dy over dx is equal to some type of equation. So the first thing that you really want to do is you want to separate your equation, so that way you have really just anything that involves y or has y in the equation on the left, and you need to get all of your x's and constants and anything that involves x on the right. So we're basically going to be separating that dy over dx. So that way it's dy on the left side and it's dx on the right-hand side. And then once you have that, then you can integrate both sides, and then you can really solve from there. All right, so just jumping in here to this first example. We have dy over dx is equal to 6x squared plus 6x plus 2. And then they give you a specific value of your function f of -1 is equal to 2. That is basically that component of this problem is going to be used here in a little bit to find out what the value of c would be. Because if we take the antiderivative, we're going to end up with that plus c. So we're going to use that information here in a little bit to actually get that value of c officially. So question number 1. We got dy over dx. The first thing I need to do is, I got 2 different expressions there, dy and dx, that are both on the same side. On the right-hand side, I have basically every term that has an x in it, and I have my constant already over there as well. So what I can do with this problem is I can multiply both sides by dx. Basically, dx divided by dx would be 1, and all you're left with on that side is just dy. And then we would have 6x squared plus 6x plus 2 dx on the right-hand side. Now we're to the part where I really have separated my variables. I have all of the x's on the right-hand side. I have all of the y's on the left-hand side. Now I'm going to integrate both sides of my equation. So I have the integral of 1 dy. So what is the antiderivative of 1? With respect to y, it would just be y. What is the antiderivative of 6x squared plus 6x plus 2 with respect to x? Add 1, divide, add 1, divide, add an x plus c. So we'd end up with 2x cubed plus 3x squared plus 2x plus c. And there's really no point on this other side, on the left-hand side, to write y plus c, because I'm going to have to get that y by itself anyway. So when I subtract c from both sides, one constant minus another constant, who knows what that constant is going to be. So I'm only going to add the c on the right-hand side. So that right there is our general solution to our problem. So now I'm going to use the value that they gave us to find our particular solution for when f of -1 is equal to 2. So I'm just taking -1, plugging it in for x, we're plugging 2 in for y, and we're solving for c. And we find that c is equal to 3, which makes our function 2x cubed plus 3x squared plus 2x plus c, which I know if I took the derivative of that, we would end up with 6x squared plus 6x plus 2, which is what we had to begin with. All right, so that's basically the idea of this entire unit. We really need to separate the variables. X is on one side, y is on the other, and then we can integrate both sides and then solve for y. And then that tells us what our answer is. So question number 2. On the right-hand side, we have all x's. We have dy dx on the left. So I'm going to multiply both sides by dx. So that way I have just dy is equal to 1 plus 12x to the 3/2 power over 2x to the 1/2 power dx. Notice all of my x's and constants are on the right, and I have my expression that has a y contained on the left. What they're doing right here is basically rewriting it in standard polynomial form. So they're taking the x to the 1/2 back to the top. They're going to distribute the x to the -1/2 to both of these inside terms. And then they're also going to go ahead and divide by 2, which is where the 1/2 x to the -1/2 plus 6x came from. Here, it's now integrate both sides. So the integral of just 1 dy is just y. And then I'm integrating the right-hand side, the plus c. Now I'm going to use this f of 0 is equal to 2 to find out what c is equal to, so that way I have my particular solution. At that point, I don't have to go back and solve it for y to get my final answer because it's already solved for y. Question number 3. This is the first one. It's a little bit different. We have dy over dx is equal to x squared plus 2x over 2y. So the first thing I would need to do in this one is separate my variables. So what we can do is just cross multiply and set them equal to each other. That's going to leave us with 2y dy is equal to x squared plus 2x times dx. And that is exactly what we've done when we cross multiply. Our y's are on the left-hand side, our x's are on the right. And now from here, we're going to integrate both sides. So the integral of 2y is 2y squared divided by 2, which would just give us y squared. The antiderivative of x squared plus 2x would be 1/3 x squared plus c. Now I'm going to use the fact that f of 0 is equal to 2 to find out what my value of c is. So plug in 0 for x, plug in 2 for y. We just have to make sure that we square 2 because it is y squared. And we get c is equal to 4. So at this point, we know that y squared is equal to 1/3 x cubed plus x squared plus 4. Now to get my particular solution for f of x, I need to solve this for y. So I would have to take the square root of both sides. When I take the square root, it could be a positive or negative root. And we would actually have to think about which one of those roots would actually give us the correct answer. I know that if I plug in 0, I need it to equal 2. So if I plugged in 0 in for these x's, that's gone, I just end up with 4. The square root of 4 is 2. Does that need to be positive or a negative root? Well, it would have to be the positive root. Negative wouldn't be the correct one, so there is our correct answer. It's the positive root. Question number 4. dy over dx is equal to x plus 2 over y. First thing I would need to do is cross multiply. So that way I'm separating my variables. So I have y dy is equal to x plus 2 dx. Then I can integrate both sides. So once again, we have y squared is equal to x squared over 2 plus 2x plus c. Now we can plug in 1 for x and negative 3 in for y. We need to find out what that value of c is. In this case, it's equal to 2. Now from here, I need to take this equation. Now that I've solved for c, I'm taking this equation and I need to solve it for y, and that is my solution of this differential equation. So what they've done is they multiplied both sides by 2, which is why it ends up being x squared plus 4x plus 4. Then you need to take the square root of both sides, and it can be positive or negative. And now I have to think about, all right, if I plugged in that information, would it need to be the positive root or the negative root? So I know if I plug in 1, 1 squared plus 4 times 1 plus 4 is 9. When I take the square root of 9, does it need to be positive or the negative root to equal negative 3? It would have to be the negative root. So the negative root in this case is my solution. All right, on to the next page. Just looking at some more examples becomes a little bit more in depth. So here on the left-hand side, all right, I got dy dx. I'll move my, there we go. Dy dx is equal to x to the 4th times y minus 2. All right, so the easiest thing would be, all right, let's go ahead and take the y minus 2 and move it to the denominator so it ends up as y minus 2 to the negative first power. The only reason why we would do that is so that way we can cross multiply. I can cross multiply, and I would end up with all of my y's on the left, all of my x's on the right. So here I have 1 over y minus 2 dy is equal to x to the 4th dx. Now we can integrate both sides. Well, I know that 1 over y minus 2 is going to end up being the natural log, because what is the derivative of y minus 2? 1, which is in the numerator. So I have the derivative over the original. That's the natural log. So I have the natural log of, once again, the absolute value of y minus 2, because it has to be positive, is equal to x to the 5th over 5 plus c. All right, so now I need to find out what my value of c is. So I'm plugging in 0 for x, I plug in 0 for y. We end up with c equaling the natural log of 2. All right, so moving down here. Now that I know the value of c, we need to find our particular solution. So we go back to here. The natural log of y minus 2 is equal to 1/5 x to the 5th plus the natural log of 2. To solve this, we're going to have to exponentiate both sides. So we take e to both sides. That's going to leave us, these two things would cancel out. So I have the absolute value of y minus 2 is equal to e to the 1/5 x to the 5th plus natural log of 2. I can separate that out because it's basically the opposite. If you have two things with the same base being multiplied, you would add them. So now I'm just separating it back out as e to the 1/5 x to the 5th times e to the natural log of 2, because e to the natural log of 2 is just equal to 2. So that 2 becomes our coefficient. So now I'm solving an absolute value equation. I know that absolute value equations, the inside of our absolute value could be positive, or you set it equal to negative. So now we just go through and add 2 to both sides, and I plug in 0 and 0 and figure out which one works. In this case, it's the right one. All right. That next example is pretty much exactly the same, just different numbers. You just need to make sure you check at the very end, if you plug in your answer, which one of those would actually give you the correct one, and then choose that one. This is a good one right here, the 2000 AP Calc AB question number 6. This could potentially be what it looks like on your AP test. And we're gonna look at many other examples. I'm still trying to figure out how they're going to do this online and what it's going to look like for you guys. But on this one, we have dy over dx is equal to 3x squared over e to the 2y power. I would cross multiply to separate our variables. That's key, the separation of our variables. So then I have e to the 2y dy is equal to 3x squared dx. We would then integrate both sides. This one becomes a little bit more complicated because I'm integrating e to the 2y. So this is an integration of composite functions, which is what we talked about on Tuesday. So, do I have the derivative of 2y showing up with our integrand? No. So I would need to place a 2 there and a 1/2 out front. That becomes a little bit more complicated. From there, it's just a matter of, integrating both sides, plugging in the value that they gave you, and then going back and rewriting it and solving it for y, and there's our answer. Find the domain of find the domain and range of the function. The domain of a natural log function is going to be where the argument is greater than 0. So I can just set that greater than 0 and then just solving and then writing my domain. And just a reminder about the natural logarithms, or just all logarithms in general, the range is always negative infinity to positive infinity. The next page is just a couple of review questions. I'll let you guys look at those. But basically, the main part of this was the separation of variables, solving differential equations. All right. Make sure you guys do the day of homework that's with this. You basically will have Thursday, Friday, Saturday, and Sunday to do this. And then we have one more thing that's getting posted. I'll post it on Monday. That's talking about slope fields. And then after that, we're going to go back and start reviewing stuff before we take the AP tests.